Okay, so we're going to start on project 4, and this is going to cover risk portfolio construction in the efficient frontier. And we're going to start out by calculating betas for your stock and beta for your portfolio. And then we're going to do a mean variance analysis. We're going to draw the mean variance efficient set of portfolios so that you can look at the efficient frontier. So that's where we're going on this project. I'll try to bring in as much finance while I'm teaching you how to do the project as I can. So we're going to start out by doing betas. So the first thing we're going to do here is we're going to open up our spreadsheet for project 3. I've already got mine open over here. And the first thing we want to do, and I've already done it on this one, is to delete the spreadsheets that have the distributions of returns. So the three spreadsheets, one for the S&P and one for each of the two other stocks, so that showed the histograms. So delete those spreadsheets so that you wind up with just the returns spreadsheet. So I'm going to get my pen out here. So we're going to add another column of returns here, and we're going to make this a portfolio of our 5 stocks. I need to stop inking. There we go. And this is I'm going to call it our portfolio. And it's going to be 20% times the return for each of the stocks. But we don't need to worry about that here because we're equally weighting. We just use the average function. So that works just fine to use the average function. And to relate that to finance, remember that what you learned in 3312, and I'll just take this to a blank part of the spreadsheet so I can write on this. And what you learned in 3312 was that the return on the portfolio is equal to the weighted average of the returns on the individual assets in the portfolio. So if you have a 2-asset portfolio, this would be the return on the portfolio. In general, it's equal to the sum from, I'll call it J equals 1 to N of the W of J, so that's stock J, times the return of stock J. That's the return on the portfolio. Okay, so we're going to calculate that in that same way by taking the average of the returns on each of the 5 stocks in the portfolio. Okay, so that's already done. Number 3 says calculate the mean monthly return, standard deviation, skewness, and kurtosis for the portfolio down here where you did everything else. And I've already sort of inadvertently done it. So I'm going to hide these 5 columns so that I can see what I'm doing here. This is the arithmetic average, etc. So I need to get rid of that stuff. That's one problem with the double clicking, is that it will take it all the way down to the bottom, and we didn't want that. So now I'm going to take this arithmetic average, these 4 things that I want, and I'm going to copy those formulas. And since they're using relative referencing, they're going to reference the cells above. So that's going to give me the portfolio average, the portfolio standard deviation, the skewness and kurtosis of the portfolio. Okay, so that's number 3. So number 4 says, using 5 years of data, run separate regressions between the S&P 500 returns and the returns on each of the 5 stocks and the portfolio. So this is where we are right here. I'm going to show you how to do one of them, and then I'm going to stop the video because I don't want it to be too long, and let you do the other 5. And I'll give you a little instruction on that. But first I want to talk to you a little bit about the finance component. Okay. So what you learned in 3312, and if you're taking 3316, you will have learned that too. Learn it there too. Is that the return on a security, so security J, is equal to the risk-free rate plus beta times RM. I need to give myself a little more room here. Minus RF. Not sure why it's jumping around like that. So now what we're going to do here is calculate the beta. So we're going to use regression analysis to calculate the beta. So we've got the return on the security and we've got the free rate. We've got the return on the market. But what we're going to do is we're going to take out this risk-free rate. The big difference here is beta times the risk-free rate, negative beta times the risk-free rate. But just for ease of calculation, and because most of the time the calculation is actually done this way, we're not going to include the risk-free rate. We're just going to let that be an intercept that's going to be defined by the regression that we do. So we're just going to run this regression. Rj is equal to alpha, which is the intercept that Excel will put into the equation, plus beta times the return on the market. So as in any line, this is your y and this is your x. So beta would be m, right? Y equals mx plus b. Y is the dependent variable, x is the independent variable, and m is the slope. And b is the intercept. So if you remember, boy, that's terrible. Let me erase that. I like that I can erase only one line. Try to make it at least semi-straight. So if you remember in basic math, that's going to be like this. If you have a line, this is m, this is x, this is y, and this is b. So that's just the equation of a line. So that's what we're doing here. We're going to run a regression analysis, and we're assuming that everything's linear. Okay, and beta, if you will recall, is the measure that we use, for systematic risk. So that's systematic because the only thing it's measuring is the risk of the market, the effect of the market return on the returns of the security or the portfolio. So we're going to start with, I don't want a pen, okay. I'm going to start right here. And the first thing we're going to do is unhide this data because I need to be able to see the data in order to use it. Okay, and then we're going to start following the instructions. So that says data, we use data analysis, regression, and the Y range, as I just showed you, is the security return. So first I'm going to do ExxonMobil, and I'm going to come down to 5 years of data. Let me do this so I can see the dates. I started with August of 2016, so I'm going to go through September of 2011, and I'll show you an easy way to figure that out. Make sure that you've got 60 returns, or 5 years. The X range is the S&P, just like I said a minute ago, and you have to use the same number of observations, so go through September. I'm going to put it in an output range, and the output range is going to be over here. And I'm going to push OK. So this is going to give me a regression like the one in the slideshow. And this right here is the beta. So it's 0.78. I can look at the t-statistic and see that it's significantly different from 0. The p-value is small, indicating that it's significantly different from 0. like I talked about in the lecture video. And here's the adjusted R squared, which we also talked about in the lecture video. All those other statistics are here as I talked about. I'm going to write ExxonMobil right here, so I know that it's ExxonMobil that I'm doing. And I'm going to show you one more just so that you can see there's one thing you have to be sure to pay very close attention to, and that is not to overwrite the data that you've already done. So I can leave the X range in there because that's the S&P. So I'm going to substitute Southwest Airlines, LOVE, for ExxonMobil. And the key to remember here is that I need to change my output range. So I'm going to put my output range below the ExxonMobil, otherwise it will overwrite ExxonMobil. Okay, and there's my beta for Southwest Airlines. And I'm going to write LOVE right here. And then go ahead and do the other three stocks and the portfolio that you just created, this one, in column K. And I will continue the video from here.